Now let's continue on our lesson on section 11.3. We talked about average rate of change with a closed interval. Now we're talking about instantaneous rate of change. Now this case structure is our first exposure to calculus. Using the difference quotient at a designated x value. And what instantaneous rate of change is the velocity of the function at a specific x value. All right. And now we're getting very precise at what is happening with the movement of the function. Is it going up? Is it going down? Is it moving fast? Is it moving small? If it's a fraction, it's moving small. So let's look at the formula and look at how we're going to deal with this formula. The instantaneous rate of change of a function f when x equals some given value is the limit as h approaches 0. H here is the very small change. By x value given of the function. And notice this part is going to be a lot of math, but it's easy math. It's the function of the a plus h minus f of a, all right, all divided by h. Now, the alternate form is f of b minus f of a over b minus a limit if we had the parameter within what a and b is. But for right now, we're looking at this next example to explain to you what is going on with the function. Here we have a function that is an s of t. This means it's moving. Imagine an arrow thrown in the air, a gun or cannon flying, being initiated. All of this is movement. So we have an s of t function, and t is time. Time can be mainly in seconds because we're moving very fast. So here we go. Suppose the position of an object moving in a straight line is given by s of t equals t squared plus 2t plus 4. Find the instantaneous velocity when t is 1. All right. So we're going to have to take the limit as h approaches 0 for f of, in this case, it's x plus 1 minus f of x. And let's look at our formula. Let's see how we have it. Yes. All over. And I'm going to write it as h because it's going to mess me up. So we're going to say h. F of x plus h minus f of x all over h. Let's do it this way. Let's do the difference quotient and then take the limit as h approaches 0 and then insert what the x value is. So let's do the math. And we're going to have s, well, I'm going to have t plus h squared plus 2 times t plus h plus 4 minus t squared plus 2t plus 4, all divided by h. And then we're going to take the limit as h approaches 0 to find the functional value of this. And we're going to do FOIL t squared plus 2 th plus h squared. Now do distributive property tt plus 2h plus 4. And I'll do distributive property of the negative 1, t squared, minus 2t, minus 4, all over h. Now we're going to look for additive inverses, and all the t's alone should be done. T squared, negative t squared. 2t, negative 2t, plus 4, minus 4. So we're left with the following. The limit, oops, got the wrong color, as h approaches 0 of 2th plus h squared, and we're dividing that by, and plus 2, sorry, that's an h right there, 2h, sorry, plus 2h divided by h. Now we're going to factor out an h. Always, always, we're supposed to factor out h. Limit as h approaches 0. And we're going to do 2t plus an h plus 2 divided by that h. So we don't have to worry about the 0. Now we take the limit, therefore we end up with 2t plus 2. And this is our function for all points of f of x for instantaneous rate of change. All right, so now what we want is the instantaneous rate at x equals 1. All right, so now as we do this, we're going to put our function, I'm going to put 2 times the 1 plus the 2. So we get 4 is the instantaneous rate of change. Or velocity. X equals 1. And it's velocity. All right. Well, we're going to do one more problem and in instantaneous rate. And then we will look at other conditions for this. Suppose the position of the object moving in a straight line is given by s of t equals 5t squared minus 5t minus 5. find the instantaneous velocity at time equals 4. So we're going to take the limit as h approaches 0 of s of e plus h minus s of t, all divided by that h. So let's do some math. Now remember, in the second course, we're going to take rules to remove the need for that difference quotient, taking the limit. So we're going to have 5 parenthesis t plus h squared minus 5 times t plus h minus 5 minus 5t squared minus 5t minus 5, all divided by that h. The limit as h approaches 0 is going to be 5 parenthesis t squared plus 2th plus h squared minus 5t minus 5h minus 5 minus 5t squared plus 5t plus 5, all divided by that h. We're taking the limit as h approaches 0, distributive property, 5t squared plus 10th plus 5h squared minus 5t minus 5h minus 5 minus 5t squared plus 5t plus 5, all divided by that h. Now we're going to cancel out additive inverses within that distributive function that we just did. That leaves us all our h's, like we said before. So we're going to take the limit, as h approaches 0, and I'm going to factor out, well, no, I'm going to write it out so that nobody gets lost. I'm going to factor out that h. Cancel out those h's. Now we're going to take the limit as h approaches 0 for our general function of 10x plus minus 5 is our velocity function. So we want instantaneous velocity. That's the value of our limit formula for the difference quotient at that x value. So I'm going to have 10 times the 4 minus the 5. 40 minus the 5, 35 is our rate of change, our velocity rather, at that point. Stop right there and let you digest what we've done.